up integrals of functions of two variables over rectangular regions is pretty straightforward, and we've seen that we can swap the integrals around. But what about for other shapes? Well, it can get quite complicated and fairly messy. Let's have a look why. Let's take the relatively straightforward case of integrating over a triangular region. So let's say R is the region in the triangle bounded by the line y equals x and the line x equals 1. How do we integrate over this? So the question is, can we swap these two things around? And these limits now depend on x and y. So it can become a little bit complicated, and the order we do the integration matters now. There are actually two separate ways to try this integral. We could either go about it vertically or horizontally. So we would integrate y vertically up to the line y equals x, and then add up horizontally by integrating over x. So let's try integrating vertically up to the line y equals x. And then, after that, integrate horizontally up to x equals 1. So then I can think of the region as defined as x less than or equal to 1 greater than 0, and y bound between x and 0. So I can think of the partial area function then as the area up to x, the integral from 0 to x, f of x, y, dy. So I integrate up to x along the y direction. And then the volume is just the integral over the x direction of the area function. So what we have seen then, we integrate from 0 to 1 of the integral of 0 to x of f of x. Crucially, the dy goes with the inner integral and the dx with the outer. And we now can't swap these ones around. If we wanted to integrate x first, we would then have the integral. So you can see that changing the order of integration means re-evaluating from scratch how one sets up the integration limits. In fact, choosing the order of the integration carefully can be critical as to whether you can do the integral or not. So let's say we have the function z equals y sine x over x squared, and let's choose a region as that triangular region we've just had a look at. Let's try this both ways. So the first way, so we set this integral up as the integral from 0 to 1, 0 to x. Okay, now I can do the first integral with respect to y. Integrating with respect to y, I'm doing this integral, but the x's in here I'm treating as a constant. They don't depend on y. So this becomes the integral from 0 to 1. Now I substitute for y equals x. What I'm left with is a very simple integral of the integral from 0 to 1 of sine x dx. And so that's just a half the cosine of 1. Now, if we were to try that the other way, we would then be looking at the integral from 0 to 1 and the integral from y to 1 of y sine x over x squared dx. Now that becomes a much more complicated problem, the integral of sine x over x dx. So the lesson is, be very careful of the order that you do the integrals in when your region is a strange shape. You want to use what information you can to make the integration as easy as possible.